Hello mga ka-tribes! Welcome to Daddy Brew TV. For today's video, let's have Lesson 3. Operations on Functions. Operations on functions are similar to operations on numbers. Adding, subtracting, and multiplying two or more functions together will result in another function. Dividing two functions together will also result in another function if the denominator or divisor is not the zero function. Lastly, composing two or more functions will also produce another function. Okay, what's new? What's new in this video lesson? To start with, let us try to consider this story. The title is Save for a Cause. Through inspiration instilled by their parents and realization brought by COVID-19 pandemic experience, Nea and Neo, both senior high school students, decided to save money for a charity cause. Nea has a piggy bank with 10 peso initial coins inside. She then decided to save 5 peso daily out of her allowance. Meanwhile, Neo, who also has a piggy bank with 5 peso initial coin inside, decided to save 3 pesos daily. Given the above situation, let's answer the following questions. First question, how much money will be saved by Nea and Neo after 30 days? After 365 days or 1 year? Their combined savings for 1 year. B. Is the combined savings enough for a charity donation? Why? C. What values were manifested by the two senior high school students? D. Will you do the same thing these students did? What are the other ways that can help less fortunate people? E. Do you agree with the statement of Pope John Paul II said that nobody is so poor he has nothing to give, and nobody is so rich he has nothing to receive? Justify your answer. What functions can represent the amount of their savings in terms of number of days? Okay, these questions will be answered during our face-to-face sessions. Now, what is it? In the previous lessons, you learned to represent real-life situations to functions and evaluate a function at a certain value. The scenario presented above is an example of real-world problems involving functions. This is the representation of two functions represented by a piggy bank. Nea's savings is represented by the function f of x is equal to 5x plus 10. Neo's savings is represented by the function g of x is equal to 3x plus 5. And their combined savings is represented by the function h of x is equal to 8x plus 15. In the given illustrations, we just simply combine the piggy banks of the two students. The resulting is another piggy bank. It's just like adding two functions that will result to another function. Now, let's have definition. Let f and g be functions. Number one definition, Their sum, denoted by f plus g, is the function denoted by the quantity f plus g of x is equal now to f of x plus g of x. Example number 1. Given the functions f of x is equal to x plus 5 and g of x is equal to 2x minus 1, find the quantity f plus g of x. For our solution, f plus g of x is equal to f of x plus g of x by definition. So replacing f of x equal to x plus 5 plus and g of x is equal to 2x minus 1. Then by operations or performing operations, let's combine x and 2x. That is now 3x. Combining 5 and negative 1, that is plus 4. And this is now the sum of the functions f and g. It means that when you add two functions, the result is also a function. Next, definition number 2. Let f and g be functions. Their difference, denoted by f minus g, is the function denoted by f minus g of x is equal now to f of x minus g of x. Example number 2. Given the functions f of x is equal to x plus 5 and g of x is equal to 2x minus 1, find f minus g of x. For our solution, f minus g of x is equal to f of x minus g of x by definition number 2. So let us replace f of x equal now to x plus 5 minus g of x equal to 2x minus 1. Okay? Now let's simplify. Take note that we are using the operations subtraction. So in subtraction, once you subtract a binomial or a polynomial, change the sign of the superhand. From 2x, it becomes minus 2x. From negative 1, it becomes plus 1. And then, perform the operations. X minus 2x is negative x. And 5 plus 1 is positive 6. And that is the difference of the two functions. Take note that it is also a function. Okay? Next, third definition. Let f and g be functions. Their product, denoted by f times g, is the function denoted by f times g of x is equal to f of x times g of x. Example number 3. Given the functions f of x is equal to x plus 5 and g of x is equal to 2x minus 1, find f times g of x. For our solution, f times g of x is equal to f of x times g of x. That's by definition number 3. Replacing f of x equal to x plus 5 times g of x is equal to 2x minus 1. So you can use FOIL method in multiplying the two binomials. Okay, x times 2x, that is 2x squared. X times negative 1, that is negative x. 5 times 2x, that is positive or plus 10x. And 5 times negative 1, that is negative 5. Now, let's combine similar terms. 2x squared, bring down because it doesn't have a similar term. And let's combine negative x and 10x. They differ in sign, so the operation is subtraction, but we will copy the sign of the larger number, so it becomes plus 9x. Bring down minus 5. And that is the product of the two functions. Definition number 4. Let f and g be functions. Their quotient, denoted by f over g, is the function denoted by f over g of x is equal to f of x over g of x, excluding the values of x where g of x is equal to 0. Example number 4. Given the functions g of x is equal to 2x minus 1 and h of x is equal to 2x squared plus 9x minus 5. Find h over g of x. For our solution, h over g of x is equal now to h of x over g of x. That is definition number 4. Now, let us replace h of x equal to 2x squared plus 9x minus 5 over g of x is equal to 2x minus 1. Now, let's factor the numerator. The factors are x plus 5 times 2x minus 1 over 2x minus 1. Then cancel this out. So therefore, the final answer is x plus 5. That is the quotient of the two functions. Okay? Next. Definition number 5. Let f and g be functions. The composite function denoted by f of g of x is equal to f of g of x. The process of obtaining a composite function is called function composition. Example number 5. Given f of x is equal to x squared plus 5x plus 6 and h of x is equal to x plus 2. Find the following: A. f o h of x, B. f o h of 4, and C. h o f of x. For our solution, problem A, the f o h of x is equal to, by definition, f of h of x. Now, let us replace h of x by x plus 2. That is now f of x plus 2. And then, since the given f of x is equal to x squared plus 5x plus 6, let us replace x by x plus 2. And that is now equal to f of x plus 2 is equal to the quantity x plus 2 squared plus 5 times x plus 2 plus 6. Okay, let's simplify. Let's square x plus 2. The square is x squared plus 4x plus 4. And then distribute this, that is plus 5x. Then 5 times 2 is 10 bring down 6. Okay, let's combine similar terms. Just bring down x squared. Then let's combine 4x and 5x, and that is now plus 9x. And combining positive 4, positive 10, positive 6, and that is plus 20. And therefore, this is now the composition of f and h function. Now, problem letter B. For our solution, the composition of f and h of 4, or FOH of 4 is equal to f of h of 4. Now, it means in the function h of x, which is equal to x plus 2, let us replace x equal to 4. And that is now 4 plus 2. That is equal to f of 6. Then 6 is the replacement value now of x in the f of x function. That is f of x, or f of 6 is equal now to 6 squared plus 5 times 6 plus 6. Simplify 6 squared, that is 36. 5 times 6 is 30 plus 6. Combining the 3, we have 72. And that is now the composite of f OH of 4. Okay? Letter C solution. The problem is HOF of x is equal now to h of f of x. Now, first, let us replace f of x equal to x squared plus 5x plus 6. And then, since we are looking for h of x squared plus 5x plus 6, where h of x is equal to x plus 2, meaning the replacement value of x is x squared plus 5x plus 6. And that is now equal to x squared plus 5x plus 6 plus 2. Okay, let's combine similar terms. Bring down x squared, bring down 5x, and 6 plus 2 is plus 8. And this is now the composition of h and f function, which is also a function. Okay? Thank you for watching. See you on my next video. Bye.